they stay that way. All right, welcome Matrix. It's really nice to have you all here with us again at the start of another week. We're still busy with our course on analytical geometry, and we're still talking about circles. And last time we were talking about, thank you, Camusila, yes. We were talking about tangents, and now what I wanted to do today was some more tangent questions with you, because they can actually be quite difficult. And the stuff that we've done up till now has been sort of fairly straightforward, but I wanted to show you a couple of questions this evening where things do indeed start to get a little bit more difficult. Okay, so just a little bit of revision from last time. Plus there's also something that I want you to do. I'm going to do question B as an example with you, and then I want to make sure that you guys are fine with this, and then you can choose to either do question C or question D if you're up for a challenge. So the idea is we want to find the equation of a tangent which touches the circle. So as I said, I'm going to do B as an example with you. If we want to determine the equation of a tangent which touches a circle at a particular point, okay, remember to work out the equation of a tangent, we are working out the equation of a straight line. So in other words, y equals mx plus c. All right, so what the question wants from us is for us to calculate the gradient of this tangent and for us to calculate its y-intercept as well. Okay, so generally speaking, we calculate the gradient first. We then sub in the point that it goes through so that we've got the m, the x, and the y, and then we're going to solve for the c. Okay, so now in this particular question, we don't have a picture, but that doesn't matter. How are we going to calculate the gradient of the tangent? Any ideas where we should start? We've got the equation of the circle and we have the point of tangent C. What are we going to do with this information? Boyd-Shepherd, what would you do?
First, the coordinates are -4 and 1. So with that coordinate, I'll calculate the gradient by saying -3 minus 1 over -2 plus 4, if I must say.
Okay, all right. So what you're doing then is you're working out the gradient of a line, but what line are you working out the gradient of? You've said the coordinates at this, oh, so let me just change the pen. You've said the coordinates at the center of the circle are -4 and 1, which is fine. And then we've got this point of tangency. Let's just call it t, -2 and -3. So if I now calculate the gradient of TC, what does TC represent in terms of what's going on here? Is that the tangent?
I'm not sure.
Okay, so TC, okay, C is at the center and T is a point on the circle. So that means that when you are calculating the gradient of TC, you are calculating the gradient of the radius. Does that make sense?
Oh, it makes sense.
Okay, all right. So what you are doing here is you're perfectly correct, but you need to know what it is that you're doing so that you know how to use the information. All right, so you are calculating the gradient of the radius. Why are you calculating the gradient of the radius? What are you going to do? What are you going to do with the gradient of the radius once you've got it?
We're going to solve for the gradient of the tangent.
Of the tangent, absolutely. And Cassandra, how are we going to do that? How are we going to use the gradient of the radius to help us find the gradient of the tangent? What are we going to do?
I know that tan is perpendicular to radius, meaning that I'll have to multiply my gradient for my radius with -1. I mean,
Absolutely.
when I multiply my gradient for my radius and my tangent, it has to give me -1.
That's it. Okay, that's perfect. I don't know if the rest of you heard what Cassandra said, but what she was telling me was 100% perfect. Okay, because remember, the gradient of our radius TC times the gradient of our tangent is going to give us -1. That's how we're going to calculate the gradient of the tangent. So back here to TC, we've now got, and let me hope that I don't make any silly mistakes. I know the last time the matrix were here, Nicole, I said something like 4 minus 1 is 2 or something ridiculous. But anyway, let's hope I don't make any silly mistakes like that today. Okay, all right, so I'm getting a gradient of minus 2. I hope I'm correct. So the gradient of TC is minus 2 times the gradient of the line, that is the tangent, will give us negative 1. So that means that the gradient of our tangent has to be a half. Okay, and now we can go ahead and go and sub into y equals mx plus c. And what we want to do is we want to sub in the gradient, and we want to sub in the point that the gradient goes through. Okay, sorry, that the tangent goes through. So it also goes through the point of tangency. So minus 3, the gradient is a half. X is equal to minus 2 plus c. So that means we've got negative 1 on this side. Add 1, so that would be negative 2. So therefore, the equation of this tangent, if I'm not mistaken, it's going to be the line y equals, sorry, the equation of the tangent, y equals half x minus 2. Okay, that was really good, guys. Well done. So would you say that that's really straightforward and very easy at this stage? We don't need to practice that. We can move on to something more difficult. Because I don't want us to waste time doing stuff we know how to do. Yes, so we can't, okay, all right, so you guys are fine with that, 100%. Okay, lovely. So let's move on and let's talk about some more difficult questions. All right, so here is another example for you. In the diagram alongside, M is the center of the circle, and the circle's equation is x minus 2 squared plus y plus 5 squared equals 36. BC is a tangent at C. If B has the coordinates 8 and 3, calculate the length of BC. Okay, so what do you think our starting point is, Matrix? We want the length of BC.
Ma'am, I think our starting point is finding the coordinates of C.
Okay, and how would you find the coordinates at C? Do you have enough information to be able to do that? Not really at this stage. Okay, not really at this stage. Because you see, the idea is, can you see, is, are you thinking, well, if you know the coordinates at C, then it means you can use distance formula and calculate the length of BC. Is that what you were thinking?
Yes, ma'am.
Okay, all right. And it's fair enough, and that's fair enough to absolutely think this way, but I'm asking you, can you see, and I'm asking all the grade 12s that are listening, do we have enough information with what we've been given to calculate the coordinates at C? Do you think there's enough information for us to be able to do that?
No.
No. What? So in other words, if we wanted to calculate the coordinates at C, we would at least have to be able to work out the equation of the tangent, because then we could do a simultaneous solution, couldn't we, between the tangent and the circle, and that could give us C. But they've really given us nothing about the tangent, no gradient, and certainly no y-intercept. So that means that maybe there's another way for us to do this problem, and that working out the coordinates of C and using distance formula, even though that is valid, is not going to work in this case. So let's think about something else. If we can't get the coordinates at C, how else could we possibly do this problem? What do you guys think? What do we know? Okay, Kulani, good point. Okay, so we know the coordinates at M. I quite agree. So let's put them in. We know the coordinates at M are 2 and -5, because it's a point in the fourth quadrant. Lovely. Okay, so we know the coordinates at M. That's it. So the equation of the circle tells us this. What else do we know?
We know our arc.
We know Okay, what about the radius? Okay, so the radius isn't actually there, all right? But in analytical geometry, I am allowed to draw the radius in. There's no problem with me doing that. And I know that the radius is perpendicular to the tangent as well. I know that. What else do I know? This is the hard part if you haven't been exposed to a question like this. So what you're allowed to do here, Matrix, is you are allowed to join point M to point B. And when we do that, what do we end up with? A
right-angled triangle.
A right-angled triangle, absolutely. All right, so now if we have a right-angled triangle coming into view, how can we use that to help us solve our problem, the length of BC?
Pythagoras.
We can use Pythagoras. All right, but now before we get to Pythagoras, there's just one last little bit of information that's missing. We can certainly use Pythagoras, I agree with you, but remember, if we're working with Pythagoras, we need to know the lengths of two sides to get the third side in the triangle. So which two sides are we able to calculate the length of, or do we know the length of?
Ma'am, I think we can find the length of B to M and C to M.
Absolutely. So from B to M, we can use distance formula. From C to M, we know how long that line is. Can anybody tell me? It's in the information that's been given to us.
6, ma'am.
It's 6. Yes, absolutely. Okay, so that comes from here. Okay, remember this information over here is radius squared. So if r squared is equal to 36, it means that the radius, i.e. cm, must be equal to 6 units in this case. All right, so what we're going to do is we're then going to calculate the length of MB using distance formula. So we're going to do our change in x's squared plus our changes in y squared. And that means that line MB is going to end up being I'm getting 10 units. Are you guys also getting 10 units? Yes, quite right. Okay, so I also get 10 units. Okay, and then because we've got a right angle triangle, we can say that CM squared plus BC squared equals MB squared because of Pythagoras. So that gives us 6 squared plus BC squared equals 10 squared, and thus BC squared would be equal to 64, which means that BC is 8 units long. Indeed, Kanisile, quite right. Okay, can you see that now that we've worked out that we can use a right angle triangle in Pythagoras, it's really not a difficult problem. But if we don't know that we can do that, if we don't know that we can use Pythagoras, if somebody hasn't told us this or reminded us about this, then the problem is actually quite difficult. Okay, so what do you guys think of that? Happy face, sad face? Does that feel good? Make sense? Cool. Lovely. Nice. Okay, so don't ever forget about Pythagoras. Normally in the tricks, we are not allowed to do constructions, but we are in analytical. We are allowed to join one point to another to make a right angle triangle. Okay, so that sort of thing is allowed. Okay, so yeah, just bear that in mind if they do ask you to calculate a side. Okay, so it's maybe not always distance formula is going to work. We've got to think about the theorem of Pythagoras as well. Okay, so now that being said, let's have a look at this question over here. All right. They tell us that the straight line y equals x plus 2 cuts the circle x squared plus y squared equals 20 at A and B. The first thing that they want us to do is they want us to calculate the coordinates at A and B. So how are we going to do that? The other question I want to ask you before we get started, in this diagram over here, which line is the line y equals x plus 2? What's its name in this diagram?
Line AB.
Line AB, absolutely. Okay, so that's line AB. It has a positive gradient and it cuts the y-axis over there at 2. Okay, so this line over here, AB, cuts the circle at A and again at B. So if they ask us to determine the coordinates at the point of intersection, what do? We have to solve simultaneously. Okay, we have to solve simultaneously. So we're going to take what y is and we're going to sub it into our circle and we're going to solve simultaneously. So we would do this. We'd say x squared plus, remember y is equal to x plus 2. So we're going to sub in x plus 2 in place of y squared is equal to 20. Okay, so this is a really important thing to be able to do. Okay, they will definitely ask you a question like this, I'm sure. All right, so now, squaring our binomial. What do most matrics forget about? The middle term. Okay, so remember square, double square. Okay, so we've got x squared plus 4x plus 4 minus 20 gives us 0. So that leaves us with 2x squared plus 4x minus 16 is equal to 0. All right, and then here, if you wanted to, you could use the quadratic formula. Otherwise, I would divide through by 2 and then go ahead and factorize. So I'm going to do that. So we've got x squared plus 2x minus 8 equals 0. So our factors would be plus 4 minus 2. And that means we have 2 solutions for x, which we expected. Either x is equal to -4 or x is equal to 2. And this is exactly what we wanted. We wanted 2 different solutions because we've got 2 points. We've got point A and we've got point B. How do we know which x belongs to which point?
I think the positioning of the A and the B in the class diagram.
Absolutely, absolutely. Okay, so where they are on the Cartesian plane. So because point A is in quadrant number 3, we know that it has to have the negative x value. Because point B is in quadrant 1, that has to be the positive. Okay, so we could write here at A, x equals -4. We still need to work out what the corresponding y coordinate is. So let's sub into the straight line just because that's easier. So we've got y equals -4 plus 2, which gives us -2. So therefore, the coordinates at A are -4. Let's just move that up. And -2, which makes sense for quadrant 3, doesn't it? Okay. Working out the coordinates at B now. So at B, x was equal to 2. So y would be equal to 2 plus 2, which gives us 4. So that means that the coordinates at B are going to be 2 and 4. All right, we happy with that? So what I'm going to do, because I'm going to have to rub this out so I've got space to write, I'm just going to write the coordinates of A and B up here because we probably will use them. -4, -2. And then the coordinates at B were 2 and 4, if I remember correctly. Yes, they were. Okay, 2 and 4. All right, next question. Determine the length of chord AB. All right, well, that's super easy, isn't it? Do you guys want to do that one quickly by yourselves? Length of chord AB. Yeah, awesome, Nicole. Pop the answer in the chat. Anyone got an answer yet for the length of chord AB? I get the same answer. What did you, sorry, is it Oratilwe?
Ma'am.
Okay, what did you get?
Oh, no, ma'am, I got 6√2.
Okay, perfect. 100%. Quite right. It is 6√2. Okay, yes, Watobe, quite right. Okay, so we get 6√2. Okay, nice one. We don't have to show the working for that. Well, you mean you would have to show the working for that in your tests and exams, but I'm not going to show it here because it's such an easy question. All right, now question C, determine the coordinates at the midpoint of AB. You guys can definitely do that one on your own as well. Okay, because you all know how to use midpoint formula. Do I need to write midpoint formula here, or do you know it off by heart? Just in case you don't, there it is. Okay, so the coordinates at M, the midpoint, please, matrix.
Ma'am, M is -1, 1.
Good. Lovely. Well done. Okay, so with questions like B and C, they won't be worth more than 2 marks each. 1 mark for subbing in to the formula and the other mark for the answer. Okay, nice. Good job. Well done. Let's move on. All right, now question number D. I want to do this with you because this is a question that comes up a lot, and the way that you set it out is really, really important. Okay, so that's why I want to work through this question with you. They've asked us to show that OM is perpendicular to AB if O is the origin. So if O is the origin, it means it has the coordinates 0 and 0. And as you've just told us, Watobe, we know that the coordinates of M are -1 and 1. And we know what the coordinates at A and B are. What concept in analytical geometry do we use when we want to show that one line is perpendicular to another? How do we do that in analytical geometry, matrix? Yes, Cassandra.
I think that when we multiply both the gradients, it has to give us -1.
Absolutely, absolutely. But we're not allowed to use that to prove that it's true. Okay, 100% Cassandra. So what we've got to do is we've got to work out the gradient of OM. Then we've got to work out the gradient of AB. Then we have to times the two numbers together and get -1. And then we can conclude that the gradient of OM times the gradient of AB was -1, and therefore the lines are perpendicular. So they're very particular about how we set this out. Okay, so now, first of all, the gradient of line OM. Okay, so that is going to be the change in y. So that's going to be 1 minus 0 over -1 minus 0. That gives us -1. The gradient of line AB is going to be 4 minus -2 over 2. Sorry, it's minus, which is plus really. This doesn't matter, does it? Minus 4. That gives us 1. Okay, so what we would then conclude, that -1 times 1 equals -1. We must therefore say that the gradient of OM times the gradient of AB is -1, and therefore OM is perpendicular to AB. All right, that's how we have to set it out. Okay, we cannot say this first. What I'm highlighting here in pink, you cannot say that first. Okay, because then if you write that first, it's like you are making a statement, and that is what they're asking you to prove is true. Okay, so you can't make that as a statement. It's what you need to conclude. All right, okay, so that is question D. Everybody good? Nice. Okay, so now let's move on. Determine the equations of the tangents to the circle at A and B. Okay, so now they want you to find the equations of the tangents. So now you have to put your thinking caps on and think about the previous example that I showed you and see how you can apply what we were doing up here, this one over there, to this question. All right, so what are your ideas? Well, I'll give you a couple of seconds to think about it, and then you tell me what you think we should do here. Anyone got an idea?
Ma'am,
Yes, Cassandra.
ma'am, I think that since we have our coordinates for A and our coordinates for B, we also have our gradient for AB. We can use our formula for straight line, which is y minus y1 is equal to mx minus x1.
Sure.
To find our equation for the tangent.
Okay, that I agree with you. But now, how are you going to work out the gradient of line CA? How are you going to work out the gradient of line CA? You've got the gradient of line AB, I agree with you, but is line AB perpendicular to line CA and to line CB?
No, ma'am.
No, it's not. Okay, and the problem is that line AB does not go through the center of the circle. So we can't say that MB is perpendicular to CB or that MA is perpendicular to CA because it isn't. So now we have to think about something else. You're very close. You're very close.
Ma'am,
Yes.
can I say that AM is perpendicular to CA?
Can you say that AM is perpendicular to CA? No, AM is not perpendicular to CA. There's a line that is, but it's not drawn at the moment. What line is perpendicular to CA?
OA.
No, OM is perpendicular to AB. It's not perpendicular to CA. So this is where, let's just see if
No,
there's
ma'am,
one.
OA.
There we go. Yes, OM is perpendicular to AB, but OM is not perpendicular to CA. Right, so Cassandra's put it into the chat. You're right, Cassandra. What we need here is that third side of a right-angled triangle, the radius. Okay, line OA that hasn't been drawn. Okay, your radius. That is perpendicular to line CA. And line OB, now that it's drawn in, will be perpendicular to CB. Okay. Is it possible for us to work out the gradient of OA now? It is, because we've got the coordinates at O and we've got the coordinates at A, don't we? All right, so we can now work out the gradient of OA. The gradient of OA would be change in Y. So 0 minus -2 would be 0 plus 2. Over change in X would be 0 plus 4. And that means that OA has a gradient of 1 over 2, which makes sense because the line slopes up to the right. OA is perpendicular to CA because every radius is perpendicular to a tangent at the point of tangent C. So that means that the gradient of OA times the gradient of CA is -1. Sorry, I just need to clear a little bit more space here now. All right, so now a half times the gradient of CA is -1. So therefore the gradient of CA has to be 2. Now we need to sub in a point that CA goes through. It goes through A. Remember A is the coordinates -4, -2. So at A, the coordinates are -4, -2. So now subbing into Y equals mx plus c. We can now work out the gradient. Sorry, the y-intercept. Okay, so now we've got -8 plus c is equal to -2, which means that c will be equal to 6. Okay, so that means that CA is the line y equals 2x plus 6. No, it can't be plus 6. What have I done wrong?
I think it's negatively. You just missed the minus when calculating the gradient. Half divide, well, -1 divide by half. Up there.
Oh, sorry, is that supposed to be -2, isn't it? Sorry, there we go. That's why. Sorry, I left the negative off the gradient, and that's why we've come out with, sorry, so this should be +8, so that would be -10. That's better. There we go. All right, so now that's correct. Okay, so what I've just done there now, Matrix, is something that might happen to you as well. All right. So if you get an answer and then you go back and you look at the diagram and you say to yourself, but hang on a second, that can't be right. I must have made a mistake somewhere. Let me go and see where my mistake is. And then that's why I went back and I was like, hang on a second. I should have actually looked before I went and subbed into the equation of the straight line, because after all, CA is decreasing. So it does have a negative gradient, not a positive one. Okay, does that make sense to everybody? I know I've gone through that quite quickly. Are you all right with that? Okay, so then what I'm going to do is you now find the equation of tangent CB. Now that I've done CA for you, you find CB. Okay, and I'm just going to put up here that CA is the line y equals minus 2x minus 10. Okay, I think everything else is there. Okay, so guys, you are finding the equation of tangent CB, please. Okay, can you see it? That's fine. Let's see if anybody else. Got that answer too. Mm-hmm. Indeed. Okay, quite right. All right, nice, Matrix. Well done. Okay, so indeed that is true. The equation of CB, it is the line y equals minus 1 over 2x plus 5. Okay, good work. Nicely done. All right, everybody okay? Do we understand where this comes from? No explanation required. We can move on. Okay, so now last question, question F. Determine the coordinates of C, the point of intersection of the tangents found in E. All right, so now how are you going to work out the coordinates at C, Matrix? Think about what you've just done and how that can help you.
Yeah.
Yes, Pochepo?
Sorry.
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 Okay, Pochepo, you can go. Sorry, Kanisile.
For when it comes to intersection, you say negative half x plus 5 equals to negative 2x minus 10.
Beautiful. Oh, that is lovely. I love it. Well done. Perfect. Good job. Okay, so you guys go ahead and go and work out the coordinates at C. Yes, can you see 100%? Okay, off you go, work out the coordinates at C, and then we can move on to the next question. You're very nice. Well done. Good, Kanisile. Good, Thelma. You guys are spot on. Okay, those are exactly, yeah, that's it, Neo. 100%. Nice, Matrix. Well done. That's brilliant. I'm really impressed. I teach 2 classes of Matrix, and I have a top set and a bottom set. And my top set class really struggled with this, and you guys have just eaten it up and chewed it up and spat it out. So that's brilliant. I'm really, really impressed. Well done. Okay, good going. Okay, so that means we can move on, can't we? And do another question. All right, let's go and have a look at this guy over here. All right. Me riding the unicorn. Let's move that out the way. All right, so now we have got a circle with center M. So that's the diagram down here. BE and EL are tangents at D and N respectively. The equation of the circle is y equals x squared minus 8x plus y squared minus 4y plus 15 equals 0. And the other bit of information that they have given us is that the equation of tangent BE, it is the line y equals half x plus c. Okay, so let's just fill this information in. So this line, it's the line y equals half x plus c. So we don't know the y-intercept, that's fine. The coordinates, we don't have anything else. Oh, and we know what the equation of the circle is. They've told us that that is this over here. All right. So now the first thing that they want us to do in part A is they want us to determine the center M and the radius of the circle. Okay, so and again, that is something that you guys should be able to do by yourselves without me explaining anything to you, and I'm going to leave you to do that, okay? What I will put here is that the equation of a circle, you guys know this very well now. And then I'll also just write the equation of a tangent while we're at it. Okay, off you go. You do A, please. And then you can pop your answer in the chat when you're done. Okay, so Thelma, you are hot off the press here. Thelma says that the center of the circle is 4 and 2, and that the radius is √5. Okay, indeed. Thelma, 100%. Good job. Okay, so I'm going to write that information down. Coordinates at M, the center of the circle, are 4 and 2. And your radius is indeed √5. Good job. Very nice. Okay. Second question. Determine the equation of radius MD and hence show that the coordinates of D are 3 and 4. Okay, so we should be able to find the equation of radius MD without any help. I will then show you how to show that the coordinates of D are 3 and 4. You have to pretend that you don't know that. You can't sub that information in because then you're not proving you verify. But certainly the first part, determine the equation of radius MD. You guys can do that as well. Once you've got it, you can pop it in the chat. Good job. How's it going, Matrix? Have you managed to work out the equation of radius MD? Okay, so Cassandra, They want you to, it's the equation of a straight line. So dm is a straight line. So you're going to work out the equation in the form y equals mx plus c, just like you would find the equation of any straight line. Okay, you have to work out the gradient and you have to work out the y-intercept. Okay, so Kulani, yes. So the coordinates of D are 3 and 4, 100%. But how are we going to get the equation of radius MD? We know the, I don't want to say it. I want to see if someone can come up with it on their own.
We have the coordinates of M,
Mm-hmm.
and we have the gradient of D to B, which includes D. So we have the gradient of that one, and M and D are perpendicular. So if you take that gradient multiplied by the gradient of MD, you can get -1, and then you can find the gradient of MD, which you can sub into y equals mx plus c.
Perfect, Bushle. Okay, so what we would do here is we would say a half times the gradient of dm equals -1. That's because BE is perpendicular to DM, because the radius is always perpendicular to a tangent. Okay, so that means that the gradient of line DM is going to be, let me not make a mistake here, it's going to be -2. As you had said, you know the coordinates at M, so subbing into y equals mx plus c. We've got y is 2 when x is 4, and that means that c would be equal to 10. Okay, so that would be y equals -2x plus 10. Anybody else get that answer? Does that make sense to you? Okay, so just as Bushle had said, yes. All right. And then they said, and then hence show that the coordinates of D are 3 and 4. So you're not allowed to sub 3 and 4 in any way. You've got to arrive at that answer. What do they want you to do here? What does the question want you to do? How does it want you to show that the coordinates are 3 and 4? So point D is a point of intersection. Okay, so at point D, we've got 3 things that are intersecting one another, although we only know the equations of 2 of them completely because we don't know what the y-intercept of BE is. Although I suppose we could work it out if we wanted to, because could we?
Ma'am?
Well, no, we can't, because we don't know what we're trying to prove that the coordinates of DE are 3 and 4. Yes, what's your suggestion?
Ma'am, can we say the equation of the tangent is equals to the equation of the radius? Would that help us in any way?
It would, can you see there? But the problem is that the tangent's y-intercept is unknown, and we can't calculate it unless we sub in the information that we're given, and we're not allowed to do that. All right. So whilst D is a point of intersection between 3 things, we only know the equation of the circle and of the radius, and those are the 2 that we have to use in this case, because we're not here. We have to solve simultaneously, Kulani, because we're not allowed to sub in 3 and 4. Does that make sense, everyone?
Yes, ma'am.
Okay, all right. So now the equation of the circle. Okay, it was, let's just get this down here. Oh, we're running out of time here, guys. The equation of the circle is x squared minus 8x plus y squared minus 4y plus 15 equals 0. The equation of dm is the line minus 2x plus 10. So now I'm going to sub in and I'm going to solve simultaneously. Okay, does that make sense to everybody? So we would end up with
I'm confused.
about what, Kanisile?
So, ma'am, we substituted. Wait, ma'am, can you please start again?
Sure. Okay. So Kanisile, what I've done is I've taken the equation of the tangent, what I'm highlighting in pink, and I've subbed it into the equation of the circle, which I'm now also highlighting in pink over here. So everywhere that there was a y, I'm replacing y with minus 2x plus 10.
Oh, okay. Thank you.
Okay, because at D, it is a point of intersection between the radius and the circle.
Okay.
Okay, that's why I can do this. Does that make sense to you?
Yes, ma'am. Yes, ma'am.
Okay, all right. So we're going to run out of time here, guys. Minus 40x in the middle, plus 100, plus 8x, minus 40 plus 15 equals 0. So what is that going to leave us with? 5x squared minus 40x is in the middle. And then our number term, we've got, that would be 6 plus 75. So we could use the quadratic formula or divide through by 5. That would leave us with x squared minus 8x plus 15 is equal to 0. And now when we factorize, x minus 5 times x minus 3 is 0. And therefore x is 5 or x is 3. Okay, so now if we know that the coordinates at M are 4 and 2, and x could be 5 or it could be 3, what does the coordinate at D have to be? At D, it has to be 3, okay, because it's to the left. Okay, so at D, x equals 3, therefore y equals negative 2 times 3 plus 10, which gives us 4. So therefore the coordinates at D are 3 and 4. So what's really important here, matrix, is that you do not use what they give you. Whenever a question says show that or prove, you are not allowed to substitute in the information that they give you, because then you are not proving, you are verifying. Okay, and that's not the same thing. So here they wanted us, so when they want us to work out coordinates, we have to do it simultaneously because we need a solution for x and we need a solution for y. All right, so look at your point of intersection and ask yourself which objects are intersecting at that point. Is it two straight lines? Is it a circle and a straight line? Or whatever the case is, and then you're going to use the two equations that you have all the information about. Okay. Unfortunately, we've now run out of time. What I would like you to do, though, is, and I'm going to give you the answer to this. You can try it yourself as well. The coordinates at L are 9 and 0. They tell us this later on, and then they want us to calculate the length of Ln. So I'm going to write here for you that Ln is root 24. That's the answer. Okay, and I'm going to let you figure out how we're going to work out Ln. Hint, 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 what we were talking about earlier this lesson. Right.
Ma'am, I have a question.
Okay. All right. And if you guys couldn't do it, then let me know. And then, yeah, we'll always be here. Nicole and I will always be here like 5 minutes before the lesson starts. So if you want to ask me next time, you're welcome to. But you should get Ln is root 24. Okay. Thank you for a lovely lesson, Matrix. I hope that that was useful and extended you, but also made sense and has helped.